This is Physics 2211 Lab 3. In this lab, we were charged with finding the mass of a black hole given a star's motion data and mass and the black hole's position data. And from Newton's second law, or fundamental principle, assuming that the star is only affected by the gravitation of the black hole, we can use that data to find the net force, and from that find the mass of the black hole. To do this, I used a Python model, and we found, using the Python model, the mass of the black hole to be 3.1842 times 10 to the 31st kilograms. I will now explain the Python model that I used to calculate the black hole's mass. I started off by inputting the black hole's position and the star's mass given to us, which is 1.989 times 10 to the 30th. We also inputted delta t, which is 86400 seconds. We then used the star motion data file that we were given to gather motion data. So we have the x positions and the y positions that we are gathering, and we are finding the change in delta x and change in delta y over delta t, which we know to be the velocities. We are then taking these velocities and putting them into vector form, combining the x and y velocities, and we are knowing that there is no z motion, so z is 0. We are then multiplying these velocities, initial and final, by star's mass to get momentum, initial and final. We can then use these initial and final momentums and velocities to find the change in velocity and momentum. Then we can divide delta p by delta t to get dp dt, and we know from Newton's second law that this is equal to F net because of our assumption. We can also find the components of dp dt, which are the perpendicular and parallel components. We know the parallel component is equal to d mag p over dt times p hat. So p hat is of course the initial direction of the momentum, so it is p initial divided by the magnitude of p initial, which is just a unit vector. D mag p dt is the change in magnitudes of momentum divided by dt, and then multiplying these two together, we get the dp dt parallel component right here. Due to Newton's second law, we know that this is equal to the parallel component of the net force. We can then calculate the perpendicular component by subtracting known quantity vectors, which is just the total minus the parallel component, and we know that this, again, is equal to the perpendicular component of the net force. These forces are then displayed by arrows. These arrows show the net force and its two components, perpendicular and parallel. And lastly, we calculate the mass of the black hole, which is of course from the universal law of gravitation, which is F of g equals big G times both masses over r squared. Here we have rearranged that into the mass of the black hole is equal to the magnitude of the force times r squared divided by big G times the star's mass. Here we have big G equals 6.67 times 10 to the negative 11th, and we have r just to be the distance between the star and the black hole. And this gives us a bunch of masses. We did this at every iteration, and we can see that they are all the same, at least to the 4th decimal point. And so this gives us our final mass, which is 3.1842 times 10 to the 31st newtons. Now we will move on to the what does it mean question. So we should discuss how F net and its components are different from dp dt and its components. So, as we know, and as we use the Python program to discover, dp dt is the description of the movement of the star, which is the object in question. And so we used XY positions to find the changes in momentum over the changes in time, which is our dp dt, and that is a description of the movement. And we know F net is what causes that movement to dp dt, and we know that those are equal according to Newton's second law. To the what if question. The what if question is that our black hole that the star is orbiting around is replaced with a different black hole in the same location. We know that the star's motion remains unchanged. Alright, so if the star's motion remains unchanged, that is our dp dt, that means that F net must remain unchanged due to Newton's second law. So the cause of the motion is unchanged, and that means that if the cause of the motion is unchanged, we know that the black hole's mass must remain unchanged because nothing else is changing in the universal law of gravitation. So we would not be able to tell any difference because there would be no change in the motion of the planet, or the star rather. So because there is no change in F net, nor the change in the motion of the star, we would not be able to tell any difference whatsoever because the star's mass would be the same. So in conclusion, we have used VPython and motion data of a star to find the mass of a black hole, and thank you for watching.